So let's look at inclined string approaches. Right. Okay. So now just look at this particular problem. See, this is a very standard problem which you will find in any standard textbook of preparation for JEE. Now, if you are going to take this particular scenario, so I'm sure that there will be, in fact, two groups of students. Uh, mm, One group of students who will try to relate velocities like this. So the question here is, there is a block A connected by a string, and the string is inclined. One side of the string is inclined. Now block B is pulled down with a velocity of 3 meter per second. So let me write that 3 meter per second. And block A, it is given to you that it doesn't lose contact with the horizontal floor and it moves on the floor. You need to relate the velocity of the block A with the velocity of block B at some instant when the string makes an angle theta with the horizontal. Now here there will be one group of students, so I call that G1, another group of students group 2. So one group of students who will think that all these points here go down with velocity 3, so these points here go up with velocity 3, and then they will take the component of 3 cos theta, equate it with v, right? So all these points 3, so 3 cos theta equal to v. Okay, right. Now there will be another group of students who will take velocity of the block as v, take its component over here, v cos theta. So v cos theta, all these points have velocity v cos theta, and then that v cos theta on the other side of the string and equate v cos theta with 3. Right, now one of the two answers is correct. Okay, but then the point is not about which answer is correct. Now I'll tell you that the logic behind both the groups, group 1 and group 2, there will be majority of students who will be thinking in terms of one of these two lines, and the thought process behind the majority of these two is strictly speaking not correct. There will be very few students, in fact even those students who clear the crack JEE examinations, they tend to think in one of these two ways. In fact, one of the two answers is correct, right? uh, Now some of you would have picked this. Of course this is the correct answer, v cos theta equal to 3, but then the logic behind this is not like the block has velocity v, so the component v cos theta, all these points on the string, they will have velocity v cos theta, so other side v cos theta, and v cos theta should be equal to 3. That is if you understand the physics concepts correctly, this is not how you should be approaching this particular scenario. So in fact there are three approaches that can be taken for relating the velocities. I will tell you all the three approaches. In fact, this is part of a problem which is in the revision course for 2023 which I am creating. But let me just tell you one small aspect, just ponder upon this particular aspect. uh, do you really think that if I take a point here, that point's velocity will be 3 meter per second? Or do you really think that the velocity of this point is going to be v cos theta? Right? Just think about that. So if you had thought the answer is 3, that is incorrect. If you had thought the answer is v cos theta, that is also incorrect. Okay, so that's a very interesting point. I'll come to that aspect in a moment. But what are the three methods of approach for relating the velocities? So I'll just tell you all the three methods of approach for relating the velocities. The method 1 is to use summation of t dot v equal to 0. So you consider the uh, tension forces like this, T and T on the two blocks, and use summation t dot v equal to 0. So you will say that T into V into cos theta, that is for block A, and for block B it is going to be T into 3 into cos of 180, which will be minus 1. Summation of t dot v, this will be equal to 0. You are going to get v cos theta equal to 3. So this is one way of relating. Another way of relating is to do something like this. Method 2 of relating. Take here this length as L1 and here this length as L2, and then you take dl1 by dt. dl1 by dt is going to be v cos theta. Now here there is a big discussion behind this, how dl1 by dt is going to be v cos theta. So in fact, dl1 by dt is not strictly v cos theta. You should be writing it like this: 0 minus v cos theta. So it is in fact dl1 by dt. If you measure l1 with the arrowhead like pointing towards the pulley, the string connecting the two objects, so dl1 by dt will be velocity of the pulley along that particular arrow mark of L1 length, and velocity of the other object along this particular line. You will take the relative velocity. So dl1 by dt will be 0 minus v cos theta. And note that how L2 is measured from the pulley to the block, that L2 is measured. So we can write dl2 by dt will be equal to 3 minus 0, and L1 plus L2, length of the string is constant. I'm neglecting the dimensions of the pulley. That assumption is made over here for now. Or even if you consider the pulley to have some dimensions, means the part of the length of the string on the pulley will be approximately a constant. So L1 plus L2 I can anyway take it to be a constant. So L1 plus L2 will be constant. Differentiate this. So dl1 by dt will be minus of v cos theta. dl2 by dt will be 3, and differentiation of constant becomes 0, and you will get the relation v cos theta equal to 3. A third way of relating the velocities of the two blocks. So what can be done is make measurements like this, right? From the from the vertical line passing through the pulley, we'll make a measurement like this x, and b, the distance of b from the pulley, that distance let it be y, and this height, the pulley height from the block A, let that distance be d. Then you can write the length of the string as root of x square plus d square, which will be this length, plus y equal to constant, and differentiate this particular relation with respect to time on both sides. This is the third way of relating. And all in fact, a third method and first method is what you will generally find in books. Second method, some teachers will be teaching you how to relate it using dl1 by dt. My personal favorite is using summation t dot v. It gives you the relationship very quickly to relate the velocities of the moving objects when you have inclined strings. Okay, now the third method, you differentiate this. When you differentiate this, it is going to be 1 by 2 times. Now differentiation of uh, root of x square plus d square I'm doing. So 1 by 2 root of x square plus d square into 2x dx by dt, differentiating with respect to time, plus dy by dt will be equal to 0. So I can cancel out this 2 and 2, and x divided by root of x square plus d square. So if I consider, see this right angle triangle here, x divided by root of x square plus d square will simply become cos theta. So I'll have a relation like this: cos theta times dx by dt will become minus v, dy by dt will be equal to 3. This will be equal to 0. You will get the relation. So these are three ways, but there is a very important point which majority of students belonging to either this group or this group, they are ignoring is, if I take a point here, the velocity of this point is neither v cos theta nor is the velocity of this point 3. We will see how to understand what will be velocity of that particular point, which is never discussed, and students don't pay attention to this because JEE till now hasn't tested find the velocity of a particular point on the string over there. And so let's try to understand how that can also be done in the next discussion.